Okay, grade 11s, I want us to look at a parabolic function. So this is, it's actually DBE November 2016. Okay, so let me just take the question clear. So small letter. So the question is, it's based on f at x equals to minus 2x squared, and then plus x, and then plus 6. Now already you can see from that point, you can see clearly from this point, if I can just put it in this way, it's very easy to see that the a is actually negative here, because remember this equation is in terms of is written in terms of fx equals to ax squared plus bx and then plus sc. So it's an old paper, that's why it's not clear on the screen. So it's in this form, that equation in this form. So which means that a in that equation is minus 2, right? And then of course b is actually 1, and then c is actually 6. I'm just highlighting this, but although those things are not important, a is important because then it tells us the shape of the graph, or tell whether the graph will shrink towards what direction. That's exactly what a is important for. So but a is important, especially in this one, for the shape of the graph. Now let me just remind you that in parabolic function, if a is greater than 0, right? If a is greater than 0, it means a is actually positive. We are likely to get a minimum. Okay, so we are likely to get a graph like that. Okay, so that's what we'll get. So we call this concave up. Okay, now also I just want to explain again, if a is less than 0, right, then we get a maximum graph. So if I go back to this one, we know that this one is in actual fact a minimum. So there is the point, is that's the minimum there. Now, and then this point here I refer to as maximum in a parabolic function, right? So that's exactly what we're going to get when the graph is when a is less than 0. We get such a shape. Okay, now that is very, very important for us to understand. And also I need also to explain something here. There are two forms of this graph, although I've already indicated the first one. So but let me explain again. F at x is expressed in terms of ax squared plus bx, right, and then plus c. Now secondly, f at x is expressed in terms of a into x minus p squared, then plus q. Then I'm going to repeat this. F at x is expressed in terms of a, x plus p, then squared, and then plus. Sorry, here I want to use minus, then minus q. Okay, now it's important for me to do it in both ways, because it's important to understand that p represents what we call a horizontal shift. Okay, horizontal shift is in two ways, in two sides, né? So this one specifically, I'm gonna explain it, so I will go straight to it. So it's in two sides, left or right, né? So the shift here is horizontal, right? But this is, especially the first one, it's horizontal and the direction is to the right side. Simple, né? But now in the second equation, remember that p is positive. So obviously in that second equation, it simply means that this one, of course, is a plus. So when I look at this p here, specifically this one, this p, you will notice that because p is positive and then the shift is to the right, so the shift is to the left. Yes, shift to the left. Okay, so that's it. And then